We are discussing about the sequence diagram. In this sequence diagram, we will be specifically talking about the notations and the symbols, because our aim is to draw a sequence diagram. So what are the different notations and symbols we'll see? The first thing is, this sequence diagram is coming from UML. UML is Unified Modeling Language, and in order to make a software, for example, in order to make a house, you need a model. So in order to make a software, you need some models, and that model will be made in modeling language, which is UML. So this comes under the field of software engineering, and here we want some standards. That is, this UML is a standard to design a system, to visualize the system. So this UML, Unified Modeling Language, this guides the creation of different types of diagrams, like the interaction diagram, like the structure diagram, like the behavior diagrams. So sequence diagram is the most commonly used interaction diagram. So the question comes, what is an interaction diagram? An interaction diagram is used to depict or show the interactive behavior of a system. That is, in a system, different components, part, how they interact. Because we are talking about object-oriented programming, analysis, programming, design, etc., etc. So here we have a class, and then we have instance of class, which is objects. How these objects interact with each other, how the functions they call, in which order. So sequence diagram is an interaction diagram, and this is also depicting interaction between the objects. As I just suggested, objects, they are instances of the class. So objects in a sequential manner, sequential order, that is the order in which these interactions will take place. If somebody says event diagrams or event scenarios, same thing. They are talking about sequence diagram. So sequence diagram describe how and what order the objects in a system function, or how they function in a particular order. Sequence diagram. So we are talking about objects. Again, we are talking about classes. The objects are going to call functions. This is how things happen. So either you are a software developer or a business person, you need this model. You need this sequence diagram in order to make a good software, to design and to finally program it, and to finally make the software which is required by the user. So this is a very important aspect of design, sequence diagram. First thing, before we go to the actual these symbols, we have Cartesian coordinate system. We always talk about the x-axis and the y-axis. In sequential diagram, we are talking about these two, that is the positive x-axis and negative y-axis. So in this direction, different, so this negative y direction, time, this is a time, you can say it is a time axis, and x is how the order or the message passing will take place, right? So you're making a software, somebody is using, somebody will use it, so that will be an actor. So actor in a UML diagram, it is representing a person, a human, or some component or a subsystem which is interacting with the software. So actor is always outside the scope of the system. That is, please remember, actor who is going to interact with your system or a software, and it will be outside the scope of the system. It will not be a part of your software. It is going to deal with the software, work with the software, but it is outside the scope of the system. Actor. This is a stick, human man stick diagram. This is how it is shown. Let us take an example. User. Now a user, if he or she is taking the ticket or wants some seat, wants to do some payment. So a user has to insert the card, he has to give the date, when the seat is offered, he has to select, he has to submit the order. When the order is confirmed, he has to get that order also. So who is doing that? User. But the system is important because system is functioning to cater to all these services which is required by the user. The user is an actor external to the system. Coming to one more aspect of your sequence diagram, which is lifeline. Lifeline and messages are two core aspects. We'll talk about messages just now. But the lifeline, you see here there is a box. And this box, there are two things separated by colon. So in this colon, the left is your object, the right is your class. So we make a box like this. There is a colon on the right hand side. We write the class name. Sometimes you don't have to write the object name. You can just underline the class name. You can leave the object name. But when you want to refer or want to give the object name, you have to give it on the left hand side. So this class 1 here is the class name, and this X is the instance of that class, which is the object of this class. This line which is coming down, the dotted line, or you can say a line with breaks, is the lifeline. That is, this is a time access for a particular object. Lifeline. So lifeline, this every object, every class will have their own lifeline. So lifeline is a named element that depicts an individual participant in the sequence diagram. Lifeline and messages, they form the core. So what are the messages? So communication between the object is shown, represented using the messages. So we use the arrows. So message appear in a sequential order on the lifeline. So there are different kind of messaging. So as I said, lifeline messages, this form the core, you can say the basement of a sequence diagram. We talked about lifeline. Let us see the messages first. So there are numerous type of messages in the sequence diagram. You see here we have, this is a very simple example of customer and bank. So we have a synchronous message, we have asynchronous message, create message, destroy or deletion message, self message, and the reply message. So let us see them one by one. The messages can be broadly classified or categorized into two. What are these? One is synchronous message, the other is asynchronous message. Synchronous, asynchronous. So this synchronous message will wait for a reply. Because if the interaction wants to move forward, it will wait. It will not just start and without waiting for the reply, or without the reply is coming, it won't send anything else. So the sender waits until the receiver has completed the processing of the message. It will wait. This is sender, this is receiver. Sender has sent something to the receiver. Until receiver sends something back, sender will not move forward. The caller continues only when it knows that the receiver has processed the previous message. That is, it has received a reply message. So here the synchronous message is represented by an arrow, and this is a full-blown arrow, that is solid arrow. That is, we use a solid arrow head to represent a synchronous message. That is, it will wait for the reply. How about asynchronous message? It will not wait. Just, you can say, the complementary of the synchronous. An asynchronous message does not wait for a reply from the receiver. The interaction moves forward irrespective of the receiver processing the previous message or not. So we use a line arrow, directed arrow, you can say. Previously it was a arrow with this arrow mark being filled. Here it will be just a directed arrow. This is the difference between the depiction. Coming to the create message. So sometimes you want to create an object in between. Every time you don't have objects at the start. So we will use this create message to instantiate a new object in the sequence diagram, because these are objects. We have already seen in the previous part that these are different objects. We have lifelines, but not always these objects are created every time in the initial stages. Sometimes you have to create in between. For that you create. So these are the situation where a particular message call requires the creation of the object. So you have a dotted. How do you represent it? With a dotted arrow, and create a word labeled on it, specify that it is the create message symbol. So sometimes people write create with a double arrow closing and ending, and also in between also. That is, if you are, example, creation of a new order on an e-commerce website, this will require a new object of order class to be created. So here you will use create message. So how do you know that this is create? With this word you will have to write create with the angle brackets, 2 angle brackets. Now once you have created the say object, you need to close it, or you need to destroy it also sometime in between. So we use this delete message to delete an object. So especially what are you doing? You are deallocating in memory. So you are making an arrow and putting a cross sign. So it is represented by an arrow terminating with an X, big X. Okay, so this is the scenario. Order is being received by the user. The object of the order class can be destroyed now. So here a proper delete message, and you don't have to write anything. You can just put a cross. It means deleting a message. So you are deallocating the memory also, and this object will be destroyed. Self message. There are certain scenarios or events where the object needs to send a message to itself. If you are related to programming, you might be knowing what I am saying. So these messages are called as self messages, and then represented by a U-shaped arrow. So this is a lifeline. Here you see a U-shaped arrow. That is, the object is messaging itself. It's sending message to itself. This is a self message. For example, we have a scenario where say a device is there, and it has an inside embedded say webcam. It wants to open the webcam by itself. So device has to call itself. So this is representing or represented using a self message. So this is a device which wants to access a webcam. So it has to send the message to itself. So this is accessing of a webcam. Here we use the self message. You see this self message U-shaped is on the same timeline, same lifeline. Coming to reply message. So all the messages we have sent, we need to get some reply also. Sometimes we want, sometimes we don't want. Asynchronous, synchronous. Some messages wait for the reply, some doesn't. But there will be a reply. So this reply message, these are used to show the message being sent from the receiver to the sender. Previously we talked about sender to receiver. Here receiver to the sender. So this is the return or reply message. We use an open arrowhead with a dotted line which you see here. So the interaction moves forward only when the reply message is sent by the receiver. So this is a reply message. You will see more often these reply messages, and as I said, represented by arrowhead with dotted line. Just consider this scenario where we are talking about a device which is requesting a photo from the user. So when it is asking for the photo, there will be a reply. So this reply is like this. So the direction will always be the opposite of the previous one. That is, reply sender, then sender to reply the receiver. Found message. What is the found message? See, this found message we will use where an unknown source sends the message. The source we don't know. It is sending the message. So unknown source is there. So it is represented using an arrow directed towards a lifeline from an endpoint. For instance, we have say a hardware failure. Here the unknown source is sending the message. So we'll make a round, you can say a filled circle, and then we direct it towards the lifeline. So this is how we represent. So say it can be multiple reasons. The example we are taking, it may be hardware failure. For example, we are accessing a webcam. Sometimes there may be failure. We don't know. So for that, we have to have a round filled and an arrow pointed towards the lifeline. Found message, and with this we have a lost message also. What is this lost message? Now here we are talking about the recipient is not known. When the recipient is not known to the system, who is sending it or who is going to get it? Recipient, who is going to get it? So this is represented using an arrow directed towards an endpoint from a lifeline. For example, say a warning is being generated. Then you will use this arrow directed towards an endpoint from a lifeline using an arrow directed. This is how it is being shown. For example, if you see here, there is a warning being depicted. This is all going on, opening application, accessing webcam, etc. But here it's recipient. So we send a message like this. This is a lost message. Important thing comes here is a guard. Now, for example, you want to say take out some money, but the balance of your account is zero. Say you want to withdraw $200, 200 rupees, but the balance is zero. So we need to have a guard situation here. So the user, or say the software developers, to be more precise, should know the constraints attached to a system or a particular process. So here the constants are what we are calling about the guard situation, guards. So here we are putting balance greater than zero, then only this will work, otherwise not. So I want to add one more thing here, very important. Here is most of the time you will be using if, else and all these constructs in your programming. So there are various scenarios which will happen. So what we'll do, we'll make a box here containing both of these lifelines, and then we'll have an if and else situation. How do we write it? We'll give a break, that is, we'll divide this into two rows. The first row will have if, the second row will have else. So if the balance is greater than zero, then you can say, okay, withdraw the money, put the or give the amount, then withdraw the money. All these process will take place, which I just discussed earlier by using different symbols. Now in else, it will just say sorry, or whichever message you want to give. Sorry, the amount is not, the balance is less, etc., etc. So this if else is important. Now the final thing which I want to tell you is the activation bar. For what time? Because the lifeline is starting from the box and ending till your page. But we are talking about what time this is active. This object is active. So this active object period is shown by a horizontal, you can say a rectangle, a bar. And this, because the starting arrow from that lifeline and the ending arrow, you can just make a box, a bar, and that is called the activation bar. This is showing that for how much time this object is active in the lifeline, which time this object was actually having a life. So I hope most of the symbols we have taken, you'll be able to make a sequence diagram now. Thank you so much. Take care of yourself.